During the Industrial Revolution, the rise of the physical machines required organizations to systematize, form factories, assembly lines, and everything we know about automated manufacturing. During the first tech boom, agile systems helped organizations operationalize the product lifestyle, paving the way for continuous innovation by clearing waste and automating processes for creation. DevOps further optimized the production lifestyle and introduced a new element, that of big data. Now, with more businesses now turning towards machine learning insights, we are on the cusp of another wave of operationalization. Hi all, I welcome you to this Edureka session on MLOps. And throughout the session, we are going to learn about the various advantages, principles, and implementations of this melting pot of a technology. But before we begin, let's look at our agenda for today. So I'm going to start out by discussing what is MLOps, followed by the requirement of it. Then we're going to go ahead and discuss a few principles or main components of MLOps without which it would not be called so. Then we're going to look in depth how does MLOps work, the various levels and processes involved, and advantages of incorporating this technology into your organization or team. Finally, we're going to summarize our entire session before we close it off. Now you can go ahead and take up this time to subscribe to us, and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn about MLOps, DevOps, and more such trending technologies, do not forget to check out our training page, the link to which will be given in the description box below. So without much ado, let's get started. So what is MLOps? Now, MLOps is the communication between data scientists and the operations or production team. It is deeply collaborative in nature, designed to eliminate waste, automate as much as possible, and produce richer, more consistent insights through machine learning. Now, machine learning can be a game changer for businesses, which is obvious, but without some form of systematization, it can devolve into a basic academic experiment. MLOps brings business interest back into the forefront of your ML operations, where ML experts and data scientists work through the lens of an organizational interest with clear direction and measurable benchmarks. It's the best of both worlds. So who can disagree? But why is it necessary? Aren't ML experts, ML engineers, and the operational team working well enough by themselves? Isn't this going to take away the freedom from your ML engineers to do what they are employed for? Now, contrary to what you may think, MLOps allows your data scientists freedom to do what they do best, find answers. It takes business decisions completely off their plates so they can build and deploy models that get you insights more quickly. Think about it. You didn't hire your data team to understand the ins and outs of your industry or your market. You didn't hire them to keep up with regulations and pipelines, so on and so forth. You hired them for their skills in acquiring information and giving you answers. So why don't you just remove the barriers and let them find answers for you? MLOps follows a similar pattern to DevOps. The practices that drive a seamless integration between your DevOps cycle and your overall operations process. This can also transform how your organization handles big data. Just like DevOps shortens production life cycles by creating better products with each iteration, MLOps drives insights you can trust and easily puts them into play more quickly. The complete MLOps process includes three broad phases: designing the ML-powered application, ML experimentation and development, and finally, operations. It is an iterative, incremental process with continuous deployment, versioning, testing, and monitoring, much like your DevOps processes. So the first phase here is devoted to business understanding, data understanding, and designing the ML-powered software. In this stage, we identify our potential user, design the machine learning solution to solve its problem, and assess the further development of the process. Mostly, we should act within two categories of problems: either increasing the productivity of the user or increasing the interactivity of our application. Pretty simple, right? Initially, we define ML use cases and then prioritize them. The best practice for ML projects is to work on one ML use case at one time. Furthermore, the design phase aims to inspect the available data that will be necessary to train our model and to specify the functional and non-functional requirements of our model. We should use these requirements then to design the architecture of our application, establish the serving strategy, and create a test suite for the future ML models. Now, the follow-up phase, which is the experimentation and development phase, is devoted to verifying the applicability of machine learning for our problem. We basically need to make sure if everything that we thought of in theory is actually doable in real time. And more importantly, is it a tangible goal to achieve? So what you do is you implement proof of concept for your ML model. So you run iteratively different steps such as identifying or polishing the suitable ML algorithm for your problem, data engineering and model engineering, and your primary goal here is to deliver a stable quality ML model that will run in production. And finally, you have your operations phase. Now, this is to deliver the previously developed model in production by using established DevOps practices, the ones you are so familiar with. You have your testing, versioning, continuous delivery, monitoring, so on and so forth. All of these terms, I hope you all are well aware of. Now, all of these three phases are interconnected and influence each other. For example, the design decision during the design stage will propagate into experimentation phase and finally influence the deployment options during the final operations phase. I hope we are very clear with this part, because now we are moving on to why we need it, or what problems will MLOps ultimately solve. Now, understand that data should always have a business focus. Operationalization helps to close the loop between gaining insight and turning that insight into actionable business value, because ultimately that is what we want. Now, in premise, it is a pretty simple concept, but the execution, unfortunately, is not so simple at all. So, adopting an MLOps approach will help your organization in three major forms. First things first, your operations team has business knowledge and your data science team understands data. Your ML experts understand ML algorithms. Your researchers understand the core concept of the project. But what lies in between all of these teams? There is a wide gulf of mismatched expertise. What MLOps does is that it combines the expertise of all of these camps for more efficient machine learning that leverages all sets of skills. Second, as ML becomes more common, the regulatory side of operations is a critical function. Run afoul of regulatory bodies, and it won't matter how much insight you've gained. MLOps puts your operations team at the forefront of new regulations and best practices, because ultimately, as we all know, all of these DevOps, DevSecOps, DataOps, MLOps, and any XOps methodologies are all about the culture. They can take ownership of regulatory processes while your data team and ML team concentrates on deploying its creative models. And finally, the bottlenecks that result from complicated, non-intuitive algorithms eases with a better division of expertise, the bigger collaboration from operations and data teams. So even here, MLOps will tighten the loop. There is a great chance that machine learning is optimizing a particular business application, but that particular application requires multiple programs and dependencies. MLOps streamlines deploying those programs and knowing which one to put into production when. Deploying machine learning effectively means way more than running numbers or leaving your data scientists on their own to figure out compliance and business insight. It's crucial to take responsibility for production level ML. So your operations team will know how to approach this new era of data that your data team is fully supported to do what they do best. Looking ahead to operations ensures that you're not only ahead of the machine learning curve, but your adoption is smooth and immediately fruitful for your company. What your company is doing to be actually termed MLOps, there are certain principles that need to be taken care of. Now, we've made a non-exhaustive list of principles. There could be more, but these are the most important. Now, the complete ML development pipeline includes three levels where changes can occur. You have data, your machine learning model, and code. This means that machine learning based systems, the trigger for a build might be the combination of a code change, data change, or model change. So all of these principles are based on these three changes. First of all, we have automation. Now, the level of automation of your data, ML model, and code pipelines determines the maturity of your ML processes. With increased maturity, the velocity for the training of new ML models has also increased. The objective of an MLOps team is to automate the deployment of ML models into the core software system or as a service component. This means to automate the complete ML workflow without any manual intervention. Now, this is ideal but attainable. Triggers for automated model training and deployment can be calendar events, messaging, monitoring events, as well as changes on data, model training code, and application code. Automated testing helps discover problems quickly and in early stages, as in DevOps. This enables fast fixing of errors and learning from your mistakes. To adopt MLOps, we see three levels of automation. The initial level with manual model training and deployment, going through ML pipeline automation, and finally up to running both ML and CI/CD pipelines automatically. In the final stage, you have a CI/CD system to perform fast and reliable ML model deployments in production. The core difference from the previous steps is that now you automatically build, test, and deploy the data, ML model, and the ML training pipeline components. The next principle is continuous everything or continuous X. To understand model development, we must first specify the ML assets as ML model, its parameters and hyperparameters, training scripts, training and testing data. We are interested in the identity, components, versioning, and dependencies of these artifacts. The target destination for an ML artifact may be a microservice or some infrastructure component. A deployment service provides orchestration, logging, monitoring, and notification to ensure that ML models, code, and data artifacts are stable. Now, MLOps is an ML engineering culture that includes continuous integration, continuous delivery, continuous training, as well as continuous monitoring. The third principle I'm going to be talking about is versioning. Now, the goal of versioning is to treat ML training scripts, ML models, and data sets for model training as first-class citizens in DevOps processes by tracking ML models and data sets with version control systems. Now, there are more than a few reasons for when your ML model or your data could change. It could be when your ML models are retrained based upon new training data, or maybe they are self-learning, or something like your data residing across multiple platforms. So, to develop reliable software systems, every ML model specification, which is the training code that creates an ML model, should go through a code review phase. And every model specification should be versioned in a version control system to make the training of these models more auditable and reproducible. Next, you have experiments tracking. Now, machine learning development is a highly iterative and research-centric process. In contrast to traditional software development processes, in ML development, multiple experiments on model training can be executed in parallel before making a decision of which model will be promoted to production. Now, one way to track multiple experiments is to use different branches, each dedicated to a separate experiment. The output of each branch is a trained model, and depending on the selected metric, the trained ML models are compared with each other and the appropriate model is selected. Such can be implemented through the means of a system like Git, which is a version control system. You could also use a weights and biases library, which automatically tracks the hyperparameters and metrics of these experiments. Now, the complete development pipeline includes three essential components: data pipeline, machine learning model pipeline, and application pipeline. In accordance with this separation, we distinguish three different scopes for testing in ML systems. So you have your tests for features and data, tests for model development, and tests for ML infrastructure. So as it is in your regular DevOps pipelines, even in MLOps, testing is a crucial part. This makes sure that testing your ML training models should include routines which verify that algorithms making decisions are aligned with the business objectives and correlate with business impact metrics. It also makes sure that your trained model includes up-to-date data or satisfies the business impact requirements, as stale models can affect the quality of prediction in an intelligent software. Apart from that, you obviously have your conventional unit testing for any feature creation, ML model specification code and testing, and model governance testing. Next on our list, we have monitoring. Now, once the ML model has been deployed, it needs to be monitored to assure that your ML model performs as expected. Now, you have a checklist called the ML test score for monitoring activities in production, which includes monitoring the dependency changes throughout the complete pipeline, data version change, changes in the source system, and upgrade in these dependencies. This picture here shows that the model monitoring can be implemented by tracking the precision, recall, and F1 score of a model prediction along with time. The decrease of precision, recall, and F1 score triggers the model to retrain, which leads to model recovery in the end. The ML test score basically measures the overall readiness of the ML system for production. And finally, you have reproducibility, which I had already spoken about in the versioning section, but I shall speak about it again because reproducibility in a machine learning workflow means that every phase of either data processing, ML model training, and ML model deployment should produce identical results given the same input. This basically ensures uniformity in delivery and setting a production standard. Now that you know all about the principles of MLOps, let's move ahead and try and understand how does MLOps work. Now, a deeper look into how MLOps works will reveal both the positive side and the problem to this process. MLOps follows a similar pattern to DevOps, the practices that drive a seamless integration between your development cycle and your overall operations process, which will transform how your organization handles data. Just like DevOps shortens the production life cycles by creating better products with each iteration, MLOps drives insights just as quickly using the same automation and iteration model. MLOps is the process of taking both data and code in order to produce predictions that prescribe which deployment to put into production. Now, a lot of you might know that there are a few steps after you define the business use and establish the success criteria. The process of delivering an ML model to a production involves these steps. These steps can be completed either manually or can be completed by an automatic pipeline. You start with data extraction, where you select and integrate relevant data from various sources for the ML task. Then you perform exploratory data analysis or EDA to understand available data for building the machine learning model. Then you prepare your data for your ML task, which involves ETL and data cleaning, where you split the data into training, validation, and test sets. And you also apply data transformations and feature engineering to the model that solves the target task. The output of this step are the data splits into the prepared format. Then you train and evaluate your model. You implement different algorithms with the prepared data to train various ML models. And the model is evaluated on a holdout test set to evaluate the model quality. The output of this step is a set of metrics to assess the quality of the model. Then you validate the model where it is confirmed to be accurate for deployment, which basically means that the predictive performance of your model is better than a certain baseline or threshold. Then the validated model is deployed to a target environment to serve predictions. It can either be in microservices with REST API or an embedded model to an edge or mobile device. Finally, the model predictive performance is monitored regularly to potentially invoke a new iteration in the process. Now, the level of automation of these steps defines the maturity of your ML process, which reflects the velocity of training the new models. So we are basically going to describe 3 levels of MLOps, starting from the most common level, which involves little to no automation, up to automating both your ML and CI/CD pipelines, which we had discussed briefly before, but now we are going to do it in a little bit more depth. So first of all is your level 1, which includes your manual process. Some people also refer to this as level 0 of MLOps. So understand that many teams have data scientists and ML researchers who can build state-of-the-art models, but their processes for building and deploying models is entirely manual. This is considered the basic level of maturity or level 1. You can see the basic workflow of this process in the diagram in front of you. You have your experimentation or development stage, and you can see all the steps that I had mentioned before, starting from data extraction and analysis straight through production. Your manual ML steps to serve the model as a prediction service. Now, in this particular model, you have manual, script-driven, and an interactive process. Every step is manual, including data analysis, data preparation, model training, and validation. It requires execution of each step by somebody and manual transition from one step to another. The process is usually driven by experimental code that is written and executed in notebooks by data scientists interactively until a workable model is produced. But the problem here arises when there is a disconnection between your ML algorithms and the operations team. The process separates your data scientists and researchers who create the model and engineers who serve the model as a prediction service. There are infrequent release iterations because the process assumes that your data science team manages a few models that don't change very frequently. Now, since there is no automation, obviously there is no continuous integration, continuous delivery, continuous deployment, nothing, which obviously leads to the lack of active performance monitoring. The process doesn't track or log the model predictions or actions which are required in order to detect model performance, its effectiveness or degradation, or other behavioral drifts. Now, this is extremely common in many businesses which are beginning to apply ML to the use cases. This manual-driven process may be sufficient when models are rarely changed or trained, but in practice, models often break when they are deployed in the real world. Models fail to adapt to changes in the dynamics of the environment, for which frequent iterations is very much required. So with that, let's move on to a higher maturity level of implementing MLOps. So the goal of level 2 is to perform continuous training of the model by automating just the ML pipeline. This lets you achieve continuous delivery of the model prediction service, and it automates the process of using new data to retrain models in production, for which you need to introduce automated data and model validation steps to the pipeline, as well as pipeline triggers and metadata management. In front of you, you can see the machine learning pipeline automation for the same. Here you can see that the steps of the machine learning experiment are orchestrated. The transition between steps is automated, which leads to rapid iteration of experiments and better readiness to move the whole pipeline to production. The pipeline implementation that is used in the development of the experiment environment is used in the pre-production and production environment, which is a key aspect of the MLOps practice for unifying DevOps. You also have modularized code for components and pipelines. To construct ML pipelines, components need to be reusable, composable, and potentially shareable across the pipeline. Therefore, while the EDA code can still live in the notebooks, the source code for components must be modularized. In addition, these components should ideally be containerized to decouple the execution environment for the custom code runtime and make the code reproducible between development and production environments. Apart from this, it also needs to be compartmentalized to isolate each component in the pipeline. So components can have their own version of runtime environment and have different languages and libraries, which basically is the core concept of containerization. So here you are beginning to see continuous delivery of models, and the model deployment setup is automated to serve the trained and validated model as a prediction service for your online predictions. So in level 1, you deployed a trained model as a prediction service to production, and for level 2, you deployed a whole training pipeline which automatically and recurrently ran to serve the trained model as a prediction service. However, when you need to try new ML ideas and rapidly deploy new implementations of ML components, if you manage many ML pipelines in production, you will definitely need a CI/CD setup to automate your build, test, and deployment of your ML pipelines. So in your level 1 and your level 2. Finally, you are at your level 3 of MLOps implementation, which is the CI/CD pipeline automation. For a more rapid and reliable update of the pipelines in production, you will be needing a robust automated CI/CD system. This automated system lets your data scientists rapidly explore new ideas around feature engineering, model architecture, and hyperparameters. They can implement these ideas and automatically build, test, and deploy the new pipeline components to their target environment. The diagram you see now shows the implementation of the ML pipeline using CI/CD, which has the characteristics of the automated ML pipeline setup plus the automated CI/CD routine. So here you can see in this setup, we have a few components. You have source control, you have test and build services, deployment services, model registry, feature store, a machine learning metadata store, and a pipeline orchestrator. You have primarily 6 stages of CI/CD in your automated ML pipeline. You have development and experimentation, where you iteratively try out new ML algorithms, and new modeling, where experiment steps are orchestrated. The output of this stage is the source code of the ML pipeline steps, which is then pushed into the source repository. Then you have pipeline continuous integration, where you build the source code and run your various tests, the outcome of which are your packages, executables, and artifacts to be deployed in a later stage. Then you have your continuous delivery. You deploy your artifacts produced in your continuous integration stages to the target environment. So now you have a deployed pipeline with the new implementation of the model. This pipeline is automatically executed in the production based on a schedule or in response to a trigger. Hence, the stage is also known as automated triggering. And so now you get a trained model that is pushed to the model registry. Then you finally have your continuous delivery model, which you serve as a prediction service for all of your predictions. So finally, you have a deployed model prediction service. You then collect the statistics on the model performance based on live data, and the output of this stage is a trigger to execute the pipeline or to execute a new experiment cycle. The data analysis step is still a manual process for data scientists before the pipeline starts a new iteration of this experiment. So that one thing we still don't automate. Now, to summarize, you need to understand that implementing machine learning in a production environment doesn't only mean deploying your model as an API for prediction. Rather, it means deploying an ML pipeline that can automate the retraining and deployment of new models. Setting up a CI/CD system enables you to automatically test and deploy new pipeline implementations. This system lets you cope with the rapid changes in your data and business environment. Now, you don't have to immediately move all of your processes from one level to another. You can gradually implement these practices to help improve the automation of your ML system development and production in your business. And among the many positives of MLOps, a few top-line benefits will directly relate to any organization's ability to stay relevant and grow in this tech and information-driven world. As most experts agree, MLOps will lead to rapid innovation through robust lifecycle management. It will help you create reproducible workflow and models. It will also enable easy deployment of high-precision models in any given location. Apart from that, you have effective management of the entire machine learning lifecycle, as well as resource management system and control for your machine learning models. From data processing and analysis to resiliency, scalability, tracking, and auditing, when done correctly, MLOps is one of the most valuable practices an organization can have. Releases will end up being more valuable impact to users, the quality will be better, which will lead to better performance over time as well. I'd like to leave you with that thought. My name is Upasna. Thank you and have a great day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!